All right, so this video is going to be graphing translations of the square root function. Okay, so this one, there's two different kinds of translations. The first one, the one we're going to do here, is where we have a value being added or subtracted to the square root term. Okay, so in this case we see we have our parent function y equals the square root of x, but then we're adding 2 to that. So again, we can do this two different ways. The easy way, which is the shortcut way that I'm going to show you, which is just doing a translation, or the hard way, which is plugging each one in and working each one out. So let's do it the fast way first. Okay, so this one, I want you to notice here that the +2 is outside the radicand. Okay, so it's outside the radical part of this function. Okay, there's another kind of translation where this plus or minus will show up inside. Okay, and that's going to be a different kind of translation. When we see the thing being added or subtracted on the outside, that's going to move it up and down on the graph. It's going to change our y value. When it's on the inside, it's going to move left and right. Okay, so this one is on the outside, so this is going to be a translation. It's called a vertical translation. It's going to go up or down. Okay, so we're going to do this just like we did the reflection. Let's do it the fast way. So we're going to take our parent function. Okay, so if we plug in 0, we know we get 0, just like before. Okay, so if we do with the translation, if we have 0, we know that we would have got 0 there. Well, we're just going to add 2 to that. So 0 plus 2 is 2. Sorry, my pen is dying on us here. 2. So 0 plus 2 is 2. So instead of at 0, it's going to go up 2 from there. So we're going to start at 0, 2. Okay, so really, as you can see, we're going to move up 2 from each spot on this function. So I don't even really have to do the rest of this. I can, and we'll do it just to make sure, but I can just come here and go up 2. I can come here and go up 2, 1, 2, go there, because it's going to have the exact same shape. We just translated, we just moved it up, okay? It's just a moving of this. We're taking this line, this whole line right here, and we're just moving it up 2 spaces, up 2 notches on the y-axis. Okay, so then this one we go up 2. This is at 3, so now it'll be 5. Okay, and then the graph would be just like that. Okay, so you can see it has the same shape. If I could draw a great graph, you guys know my artistic abilities are less than stellar. So just imagine that this is kind of a not a reflection, but it's identical. It just moved up. Okay, so if I added 2 to all these y values, okay, if I fill out this table of values, I get 1 on the x, 3 on the y, 4 on the x, 4 on the y, 9 on the x, 5 on the y. So see, that's a little bit different than the dilation. The dilation stretched the graph out, okay? This kind of translation just moves it. And we can always, just like we did before, we can always just plug in y equals square root of x plus 2, okay? Y equals square root of 0 plus 2, y equals 0 plus 2, which gives us 2. Okay, we see that there. Okay, y equals square root of x plus 2. Plug in 1 here, square root of 1 plus 2. Okay, y equals 1 plus 2. So then y equals 3. And we see that 3 right there. Y equals the square root of x plus 2. Notice that I'm rewriting the original function every time. I want you guys to get in the habit of doing that if this is the way you do it, so you don't get confused or kind of miss something. Square root of 4 plus 2. So then y equals 2 plus 2, which equals 4. See that right there. And then y equals the square root of 9 plus 2. So square root of 9 is 3. Okay, 3 plus 2. So then y equals 5, which we got right there. Okay, so this is the slow way, the long way. If we can memorize this parent function of the square root, okay, we know what this shape is. We can just do this translation, move it up to, move each one up 2 spaces, and we got the graph.